Okay, AP Chemistry, welcome back. In this video, we are going to go over how to do the first question of your pre-lab for our first guided inquiry experiment. This question is not exactly like what you're going to see on the pre-lab, but it's very, very similar. I've just changed a few numbers. So let's read the question. Given 5.6 grams of copper, how many milliliters of HNO3 are needed to completely dissolve all of the copper? And we're given that equation down below. So it's similar. It's a similar type of stoichiometry question that we've seen, where we're given grams to begin with, but this time it's asking us to end in milliliters. Okay, it's asking us to end in milliliters, and I forgot to write something here. The concentration or the molarity of the HNO3 is 15.8 molar. That's going to come in handy when we need to get the milliliters. Keep in mind that molarity breaks down into moles per liter, okay? So we're going to need to use that molarity to get to the volume, and that will be in liters, and then we can take those liters over to the milliliters. So let's write a little quick map on how that's going to work. We always start off with 5.6 grams of the Cu, or the grams of our starting substance. You know that you have to go to the moles of that first. And after you're at the moles of that stuff, then you can go over to the moles of the stuff that you're looking for. In this case, it's HNO3, nitric acid. And then once the moles of HNO3 are reached, we can finally take that over to a volume. We don't want the grams this time because the question didn't ask for the grams, it asked for the milliliters. We can go from moles to liters of HNO3 very, very easily, and we're going to use the molarity for that, and I'll show you. Once you have liters, you can finally convert liters to milliliters using a basic unit conversion. You know that there are 1,000 milliliters to 1 liter. Okay? So this one was just a couple of extra steps. It would only have been 4 if the question didn't ask for milliliters, but because we need to get over to those mils, it's technically a 5-step stoichiometry problem. So let's go ahead and get started. All right, let's go ahead and make our fractions, just like we would any stoichiometry problem, except there are 5 this time, including this one over here. And we begin with 5.6 grams of Cu. Okay. We just bring down our map to the top of each fraction to make our numerators. And then now we will deal with what needs to cross-cancel. Well, the grams of Cu need to cross-cancel, so grams of Cu need to be down there. Moles of Cu need to cross-cancel, so those need to be down there. Moles of HNO3 need to cancel, so those need to be down there. Liters of HNO3 need to cancel, so those need to be down here. Okay. Now we can go through and fill in the numbers that we need. Anywhere you see a gram with a mole, you know that mole always gets 1. And that's the only place where there's a gram with a mole. Okay? In a normal stoichiometry problem, we would have had grams up here, but that's not what the question asked for. And so now let's go ahead and go through the problem and fill in the rest of the numerators and the rest of the denominators. This is the molar mass of carbon, as you should already know. You need to look that up on the periodic table at 63.55. In this portion, we're comparing the moles of Cu to the moles of HNO3, so that's where the balanced equation comes into play. There is 1 mole of copper for every 4 moles of HNO3. All right, now here is the portion where some of you were getting lost. What do I do here? Well, I see that I'm comparing moles to liter of the same substance. What in the problem up here do you see moles per liter? or moles with liters? It's in the molarity, right? 15.8 moles per liter. So that's what I'm going to use here. There are 15.8 moles to every 1 liter because that's the concentration or the molar solubility of the substance that we're using. Now that you're at this point, it's a very, very simple conversion from liters to milliliters. You should know that there are 1,000 milliliters to every 1 liter. Show my cross-canceling. And now you just plug everything into your calculator. I'm going to do that now. And for this one, I got 22.3 milliliters of HNO3. I'm trusting that I entered everything onto the calculator correctly. Now, for your actual calculation, you should get something much, much smaller than this because I think the amount I gave you in the pre-lab was only 1.5. But everything else will be pretty much the same. I hope that was helpful and you have a little bit more of a better idea of how to do stoichiometry when you're converting to volume instead of mass and grams. In any situation where it's going to ask you to convert to the volume, you're going to need to use the concentration or the molarity of the substance. If it's a gas, well then there's a different type of conversion for that too, and we'll talk about that later. All right, ladies and gents, we'll see you on Monday. Please be sure to have the procedures, the purpose, as well as these 3 pre-lab questions done by the time we're ready to do our experiment. All right, take care. Have a good weekend.